You watched the videos and you said, I love math so much, I want to watch some more. So here you are, some bonus problems for all of you. And we're going to start with number 12 from the homework, 5.2.3. Number 12 says, find the degree and leading coefficient of the given polynomial. Let's do number 14 instead. 14 is probably more interesting. There we go. 14, we got this polynomial right here. Negative 2x squared minus 3x to the fifth. Oh, it's not in general form, right? It's not in order. Whoa. All right, let's just copy it down. Got negative 2x squared minus 3x to the fifth plus x plus 6. So again, for degree, for the leading term, for the leading coefficient. Oh, we only needed the leading coefficient, not the leading term. Oh, well. All that matters is what is the highest exponent of x? And we underline that term. So the degree is 5. That's that highest exponent of x, or whatever variable we're using. The leading term is the whole thing, negative 3x to the fifth. Don't forget that negative. It's attached. Leading coefficient is just negative 3. We weren't asked the end behavior, but if we were, it would look like this. Because it's a negative leading coefficient, so it goes down on the right. And it's an odd degree, so it behaves kind of like a cubic, kind of like a negative cubic. All right, that's number whatever that was, not 12. Let's look at 20 next. Determine the end behavior of negative x to the ninth. Well, the degree is 9. That's odd. The leading coefficient, well, there's only one coefficient. It's negative 1, right? So it's negative. Oh, we got the exact same situation. We could go to our table if we wanted. How far back is this? Right? It's an odd degree and a negative leading coefficient. What's the overlap? Ah, this thing. Again, that sort of negative cubic situation. Our end behavior is this. Or the book might write, as x goes to infinity, the function goes to negative infinity, right? As x goes to the right, the function goes down. And as x goes to the left, the function goes up. So I will take either one of these answers. The book as the arrow notation answer, but I'm okay with the little picture. Let's do number 58 next. I think we're getting close to the application problems, but not yet, I think. 58, technology. Graph the polynomial functions using a calculator, determine the intercepts and end behavior. And I believe I told you on these homework problems that you only have to look at the end behavior for f of x equals negative x cubed plus x squared plus 2x. So let's graph it. Can I just copy and paste this? I don't know. Nope, I don't think so. We tried. It was a good experience. Experiment. Negative x cubed plus x squared plus 2x. We could do this without graphing, but it's just kind of good to make a connection. So again, if we graph this, to the right, we're going down. To the left, we're going up. Oh, why are all these from this video the same end behavior? This is just another way of this same end behavior. To the right, it goes down. To the left, it goes up. And you could use arrow notation just like in the previous example too. All right. Let's do number 70 in this video. An application problem. I know it. Use the written statements to construct a polynomial function that represents the required information. A rectangle. Okay, I only got through 2 words. I know we have a rectangle on our hands here. A rectangle is twice as long as it is wide. The length is twice as long as the width. Okay, take the width, multiply it by 2. That has to be the length. Squares of side 2 feet are cut out from each corner. So from each corner, right, we're cutting out little squares from each corner. And these have side length 2 feet. I should have drawn a bigger rectangle. And they're folding up the sides to make an open box. Express the volume as a function of the width. Okay? So the volume of any box is going to be the length times the width times the height. And let's call the width x. So this whole distance, this whole width is x, which means the length is twice that. That's 2x. So the problem is, though, right, that our actual box is getting folded. It's getting folded along this line and that line, kind of. All right, and this is like the activity for this week. So the question is, once we fold these, what are we going to have? And it's really kind of hard to visualize unless you're very careful. And I can try to draw it a little bit. I might regret this. But essentially what we have an open box like so. How's that? It's not too bad, right? Well, then let's look, though, because we're bending this. This is not 2x right here, right? This was originally 2x, but it's shorter on each side, right? Because we cut out this blue thing. We cut out 2 feet on each side of this length. So now it's 2x minus 4. We lost 2 feet right here. We lost 2 feet right there. It was 2x, but we subtracted 4 from it to get where we're at. And similarly, right, this width right here, it used to be x. But again, we cut off 2 feet twice. Cut out 2 feet here, cut out 2 feet here. We lost 4 feet. What's the height of this box? Well, when we're folding it, this is the height. Right, we're folding it this way, we're folding it this way, we're folding it this way. Folding it on the blue boxes, the height is length 2 feet. We have the length, we have the width, we have the height. The volume is just all those multiplied together. Volume as a function of x is the length times the width times the height. This is the unsimplified answer. You could simplify it too if you wanted. First, outer, inner, last. Do all these pairs. V of x is going to be 2x squared minus 8x minus 4x plus 16. And we're foiling that out, but remember that's all still getting multiplied by 2. That 2 is still on the outside. So combine like terms, 2x squared minus 12x plus 16. Getting all multiplied by 2, and then distribute that 2. 4x squared minus 24x plus 32 should be our answer. All right. And voila, there we go. That's V of x. And that's this section. Good luck. Let me know if you have questions. Have a good time.